Hello everyone, we are starting a course on 3D wind turbine, 3D Savonius wind turbine, and in this course I will provide you the complete details of the CFD analysis and also validation with the well-known data from a good journal. And if you go through the data, the original reference is from the 2005, but the latest reference is 2018. And this reference, like if we go on this one, you can see here the main reference is given here from the energy journal. And if you go through the like this is the introduction and abstract, so paper is downloaded here and this is given here. Okay, so what we are doing here is that we are not going to be completing the everything, but we will be making geometry based on the data given here, and all the performance parameters for the wind turbine that you can see here. So the geometry was made based on this schematic, like diameter of the wind turbine, the diameter of the end plate, and diameter of the bucket, and the gap ratio, the shaft diameter, everything is like is given here, like you can see here. So here, if you take a look here, you can see that the dimension are given: diameter, height, the spacing, the diameter of the bucket, and the diameter of the shaft. And if you take a look on the mesh, also shown here. And what we did is that the domain shape is slightly different, that is more optimized, and like we got it from the different references. And the mesh size which is built in this paper is like a 5,83,000, but in our case this is around 2 million cells. And we have taken the same boundary condition, that is 6 meter per second, and omega is or the rotation speed is 10.4 radians per second. And at this point the torque value is around 0.6063 or something like that. And for that I have given the complete calculations actually. So this is the like introduction of the Savonius turbine, then the geometry that is like over here. We didn't model the shaft. We can, but I don't think so this is going to make much difference, but if you want we can make it. And the domain size is discussed here, that how the different domains are made. And the mesh generation is also discussed in a very detail, and every size is given in the PowerPoint slide that is going to be shared with you, and including these all files. The mesh is created here, and first cell height was kept as 0.405, and the Y plus we are getting here is less than 5. And we use a 10 inflation of prism layers. In paper they use a 15, but we use a 10 here, and I think this is enough. And the data for validation is from the same paper, and the point that we use is around here, this one, okay, 0.286 TSR. And at this point, from the web plot digitizer, the value of CP is 0.0659 Newton. This is a non-dimensional parameter. This is how we got the data. And then I reverse engineer, and from the wind power, I got the power of turbine by using CP into the P air. And so power of turbine is 0.68539 watts because the size is very small. And from the power of turbine, the formula is that the torque into omega, that's the rotational speed in radians per second. And from here we can get the torque value, and it's a 0.0659. Okay. And in the paper, the value is around 0.052 or 3 or 4. I don't exactly know here, but it's around the same value. And then time step calculation. So paper has used the they are saying that they are using the time step value of 0.007. But what we used here is that we use a 0.00167. So if I compare this value, this is like for 1 degree advancement in a one time step. So if I multiply by the 5, so that is around 0.0016635 into 4. So it looks like that's like a 4.5 degrees in a one time step. So that we can like a reverse engineer also. From total time, I can divide by the 4.5. 4.5 means 360 divided by 4.5. This will be like 80 steps. So 80. So 0.6038 divided by 80. This is the 0.007. So it is like they are using 80 time steps or 80 advancement in a one complete revolution. And what we use is that we use 360 degrees steps, 360 steps in a one evolution. That is a 1 degree per one time step. So our values will be more accurate, okay? But anyhow, they are saying that they check on the different values of the even they went not like lower than the 0.005. That is like a 3 to 3.5 degrees per time step. So, but still they are claiming that they have the good data. So maybe they have the good data at these locations. But I'm using the 1 degree for one time step. And Y plus in our case is around less than 5 that you can see here. Okay, 5.5. So majority of Y plus is like 0.2 to the 0.4. Okay. So less than 1. Every Y plus value is less than 1. So if I take the surface integrals and vortex average, and from here turbulence and Y plus, and because I only made the boundary layer mesh on the blades, not the bottom and top plate. So that's why I'm going to get the values over here. So every value is 0.36. And maximum value is, I told you, is around 5.5. That is even within the range, 5.69. And minimum value is 0.039. That's very good values actually, okay? And if you take a look on the vector plots, so you can see how the flow is interacting with the wind turbine. And I only displayed the every fifth vector. So I skipped the 4, and you can see how the flow is behaving. So if I skip only like a 2 and the every third is shown, then the data will be like this, because mesh is very fine actually. If I skip 0, all will be displayed. Okay, so we have some circulation zone that is very much common in the Savonius wind turbine. So this whole course, all these slides and the data validation is a part of the this course that is going to be commenced from the August 20. Okay, and by August 12, the fees will be half. The fees will be half. So what is the total fees? Total fees is for different categories. International students, they have the $45, so half will be $22.5. And international professional are there, then the fee is 65, so half will be around 30 USD, okay, 32.5. And Pakistan students will, they have the fees of 5,000 Pakistan rupees, and half fees is 2,500 only 2,500 rupees. And professional from Pakistan, they their full fees is 12,000, and by 12 August they will only have to pay 6,000 rupees. So hurry up and get this very nice course that is not available anywhere, and this will teach you everything from the scratch. Okay, even the basics of the wind turbine theories, and everything. Okay, and you will also get the PowerPoint slides, you will get the certificate, you will get the videos, and you will get the answers files as well. Okay, thank you very much.